Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at how to find the derivatives of the sine and the cosine functions. Up until now, we've been just looking at finding the derivative of algebraic functions. We've learned product rule, quotient rule, power rule, and we're going to continue to use those rules. But we're now extending our derivative rules to what's called transcendental functions. And transcendental functions means non-algebraic functions. So far we've just been looking at algebraic functions. And to do the derivatives of transcendental functions, we're going to be using the chain rule. The chain rule says that if you have a composite function, so you have a function inside of a function. So for example, we're going to talk about the sine of some function of x. We'll call u. So if we define that composite function as y equals a function of u and u is a function of x, then we can differentiate that y with respect to x by taking the derivative of y with respect to u and multiplying by the derivative of u with respect to x. And this is the factor that many students forget about. So we're coming back to the chain rule to explain these rules and to emphasize this du dx factor is very important. So the rules for these two functions are the derivative of y with respect to x will be the cosine of u, and then we multiply that by du dx. So that's the rule for finding the derivative of sine of a function. If we took a fairly straightforward function, let's say just said the sine of x, then the derivative would simply be cos of x. But as soon as that function gets to be more than just an x, that's when we need to multiply by our du dx factor. Very similar, the derivative of y here with respect to x, the derivative of cos is negative sine of u, and then we multiply by du dx. So again, if my function was very easy, if I had cos of x, then the derivative would simply be negative sine of x. But as soon as my function gets anything more than just x, I need to remember this du dx factor. Let's take a look at some examples. So in our first example, if we have y equals the sine of some function of x, which is x squared, the derivative of that will be the cos of x squared. And then we have to go inside the sine function. So the sine function is our outside function, and inside the sine function is a square function. So the derivative of x squared would be 2x. I don't really like leaving it in this form. I like putting that factor in front, and then we don't need brackets. If you have it behind, the brackets are absolutely necessary. You cannot multiply x squared times 2x. This factor is cos of x squared. This factor is 2x. So if you put it in front, that alleviates any kind of confusion. Let's take a look at our next example. We've got the cos of some function. So we know the derivative of that will equal the negative sine of that same function. And I'm going to put square brackets around that. And now the chain rule tells me I have to go inside the cos function and find the derivative of this. So the derivative of that will be 3x squared minus 4x plus 3. And you could leave it like that, but I would prefer to see that written out front. So negative 3x squared minus 4x plus 3 times the sine of x cubed minus 2x squared plus 3x minus 1. So it just cleans it up, eliminates one set of brackets, and we could distribute this negative as well. It's not going to eliminate the brackets, but it would eliminate that coefficient of negative 1. So that would be negative 3x squared plus 4x minus 3 times the sine of this function. So with these questions, hopefully you're noticing that the trig function is the outer function. It's the cos of something, so the derivative is the negative sine of that something. Once you've got that part, then you look inside the cos function, and now we have this, so we multiply by the derivative of that. Same thing here, it's a sine function first, and inside the sine function I have x squared. But I deal with the derivative of sine first, which is cos of that same function, and then I go inside and multiply by the derivative of that. Let's take a look at some more. Our next example is y equals the sine of some function, and this function happens to be a power function. So we actually have a composite of three functions. We have a sine function that's the outermost, then inside the sine function we have a power function, and then inside the power we have a polynomial. So when we take the derivative, we start with the outermost function, which is the sine function. So the derivative of sine is cosine of exactly this. Then I go inside my sine function, and what's next? A power. So my power rule says that I have to take the derivative of power by taking n, which is 3, times my function 2x minus 1 to the n minus 1, so squared. Now that I've dealt with the power part, its rule says I have to go inside the power function and multiply by the derivative of what's inside. The derivative of 2x minus 1 is 2. Now we can simplify this. I'm going to pull these factors out front. I'm going to multiply 3 times 2 and get 6, times 2x minus 1 squared, times the cos of 2x minus 1 cubed. That would be the derivative of this function. I want to take a look at this function because this looks very similar to this one, but it's actually very different. The way that we can think of this, this is sort of an abbreviation that it's understood when we write sine cubed. That means the whole function, the sine function, whatever is in there, the whole thing is cubed. So another way that you can look at this or think of this is sine of 2x minus 1, the whole function cubed. So in this example, the sine function is cubed. Here, the only thing that was cubed was 2x minus 1. So the approach on this example is going to be different because our outermost function now is the power. And then inside the power, we have the sine function, and inside the sine function, we have a polynomial. So make sure that you understand what the outer function is and what's inside of that function and progress down. So the derivative would be, I start with the power, 3 times sine of 2x minus 1 to the power of n minus 1, which is 2. Now I go inside this function and I take the derivative of sine, which is cos of 2x minus 1. Now I go inside the sine function and I multiply by the derivative of 2x minus 1, which would be 2. You have to remember that each function that's part of your composite function will have a derivative. Then it's a matter of simplifying. 2 times 3 is 6. I'm going to bring this cos of 2x minus 1 out front. And then I'm going to write this as sine. Instead of using these square brackets and putting my power like that, I can abbreviate that and write that as sine squared 2x minus 1. And that would be the derivative of that function. So they look similar, but be careful that you understand what the outermost function is and so on. Let's take a look at some more. In this next example, I'm going to have my independent variable be t. You might see theta, you might see other letters other than x, so I just want to do the odd example where we're dealing with other variables so that you're comfortable with those as well. But this is our cos function, and it's cos of this. So our derivative will be negative sine of that. And then we go inside our cos function and we have to multiply by the derivative of this function, Remember, pi is a constant, so 60 pi is a constant. So 60 pi times t, the derivative of that will be 60 pi times the derivative of t is a 1. Again, I would clean this up by moving this out front, so I will have negative 60 pi sine of 60 pi t. I like the cleaner look of this than this. And again, I like to get that out front so that people aren't tempted to multiply those things, because that will not work. So you may encounter an example where you have a product. And if you do that, remember you're going to be referring to your product rule, and you're going to need to identify the u, which is 2t in this case, and the v, which is cos of 5t. You also need u prime and v prime. So u prime will just be the derivative of 2t, which is 2, and v prime will be the derivative of cos of 5t, which will be negative sine of 5t, times the derivative of 5t, which is 5, and I'm just going to write that over front. In finding the derivative, I plug into my rule, which says the derivative of a product will equal u, which is 2t, times v prime, which is negative 5 times the sine of 5t, plus v, which is cos of 5t, times u prime, which is 2. In completing this, you want to simplify it by just combining some of these factors and getting rid of any of those parentheses that you can. So 2t times negative 5 will be negative 10t, sine of 5t, plus bring this 2 out front and then we can get rid of those. So plus 2 times cos of 5t. Sometimes I'll see students, they'll factor out a 2, but unless factoring allows you to do any further simplification, it's really not necessary. So I would leave it in this form. Let's try an example of a quotient. So we're asked to find the derivative of this function, y equals the sine of 3 theta over 2 theta squared. So we have a theta instead of x, but same process. And we're going to be using the quotient rule to differentiate this. So you want to have that handy, or hopefully have it memorized. And in order to use it, you need to identify the u prime, v, and v prime. So in this case, u would be the numerator, which is sine 3 theta. U prime will be cos of 3 theta times the derivative of 3 times theta, which would be 3. V is 2 theta squared, so v prime will be 4 theta. We plug all of these things into our formula. So v is 2 theta squared times u prime, which is 3 times cos 3 theta, minus u, which is sine 3 theta, times v prime, which is 4 theta, all over the denominator squared, v squared, so 2 theta squared, squared. Now we're just going to simplify and clean it up a little bit. So that's going to be 6 theta squared cos 3 theta minus 4 theta times sine of 3 theta over 4 theta to the 4th power. In this example, I can factor out a 2 theta in the numerator because it will allow me to simplify. I can cancel that common factor of 2 theta. It would simplify to equal this. So, so there will be times where factoring will be necessary because it will allow you to simplify. I want to do more examples of differentiating sine and cosine. I will have a second video and I'm going to just get progressively more challenging questions, and maybe we'll look at a couple of applications in that video as well. So practice questions like the ones we've looked at, and then when you're ready, we'll move on to the next video.